Okay. You should be getting audio now. I'm sorry, I have too many mute buttons here. Welcome to OARC 32A. This is our first fully online workshop. My name is Keith Mitchell, OARC president, and welcome, especially if this is the first time that you've come to an OARC event. Usually at this point in an OARC workshop, I say a little bit about OARC's mission statement. I think what I'd like to say this time is really that in these unusual times, we believe OARC's mission to be more relevant than ever. We're seeing unprecedented reliance on the internet infrastructure to conduct all aspects of business and everyday life and the highest volumes of internet traffic in history. This is an important opportunity to continue OARC's practice of gathering data to better understand how the DNS works and to preserve this unique event for posterity in OARC's data archives. My colleague Matt Pounsett will shortly have a bit more to say about the recent annual data gathering event that we just completed. We're also here to help coordinate and protect the smooth continued operations of critical DNS infrastructure through these challenges and to support our unique community in any way that we can. In general, OARC events have always had a degree of remote participation, and what we're doing here is we're expanding this to an even wider community online. If it's your first event, welcome, and we hope to see you again in future, whether it's online or in person. A reminder to everybody that the OARC conduct policy applies online as well as physical events. You all committed to that when you signed up for this event. The meeting is being recorded. Please also be aware of that. Please also be a member that we have at least one member of the press present. What we will do is we will convert the videos from Zoom to YouTube format over the next few days. And if there's anything you missed, you'll be able to get the presentation video as usual. Because we're using Zoom webinar mode, speakers are all muted during the event. So if you want to chat, then for this event only, we're using the Zoom chat room. Well, we're still using Jabber and some other channels, but there will be news about that shortly. These are the social media hashtags. The important thing is that each speaker's talk has got 5 minutes questions and answers. If you want to answer a question, please don't use the Zoom chat room. That is for you to discuss the presentations yourself. Please use the Zoom question and answer panel. You'll see there's a little description of the icon there to ask your questions. Type them in by text. One of our moderators will then read that out. And that's on a first come, first serve basis, time permitting. Please identify yourself and affiliation when asking. We do not have a culture of anonymity in OARC. If you need help with the workshop and anything's not working, then use the raise hand and one of the OARC team will respond to you. And that is basically it from me. What I will now do is hand you over to Matt Pounsett, and Matt is going to say a little bit about the digital collection that we just did.
Hi, everyone. I'm Matt Pounsett, the systems engineer for DNS-OARC. This is going to be really quick. It's just a bit of an update on the Day in the Life collection that we just finished last month. So for those that don't know, the Day in the Life collection is a thing we do annually and have done now for a little over a decade. Where for the same 48-hour period, a large number of the root server operators, several TLD operators, and some recursive server operators all collect query data from their DNS servers and submit that to DNS-OARC, and we make it available to members and researchers for to do sort of year-over-year research into the behavior of DNS. So this past collection this year, we had 19 contributors, just a little over 1 million capture files, and about 17.5 terabytes of data, which is quite a significant increase from the last few years. So this is the last 4 years, year over year, for the same two statistics. So we typically see a small increase of a couple of terabytes growth per year, but we saw nearly 8 terabytes of growth in the data this year, which speaks a bit to how much extra DNS traffic there is at the moment with everybody working from home. In addition, we got an extra collection this year. The HRoot server renumbered a little over 5 years ago. And since that time, they've been receiving a few thousand queries per second of traffic to the old address. They plan to decommission it in the next couple of weeks. And before doing that, they grabbed a couple of days worth of traffic from that address for people to be able to take a look at, just to see what kind of bad data is still going to an old root server address that's been out of service for a long time. And that is it for me. Have we got any questions? That sounds like no. All right, I'll pass it back to you then, Keith.
Okay, thank you, Matt. The session today is chaired by 2 members of OARC's program committee, Dave Knight and Jake Zach. I will now hand you over to Dave, who will introduce you to the speakers.
Thanks, Keith. Good afternoon for me, at least, to everyone. Our first presentation today is from Duane Wessels from VeriSign, and it is titled Intranet Redirect Detector or Pseudo-Random Subdomain Attack, Chromium's Impact on Root DNS Traffic. And I will hand over to Duane. Are you ready, Duane?
I will be ready shortly. Let me figure out this screen sharing here.
Okay.
Look good?
Looks great.
Okay. So yeah, thanks Dave. Thanks everyone for being here. This is a joint work by myself and Matt Thomas, both from VeriSign. And I should also say that we are not the first to discover this. This is something that I think people have known about for a while, and I know that Roy Ahrens was recently giving some presentations that included this. And I also learned shortly after the agenda was published from Peter Spacek that he had been engaging on a Chromium bug report site about this issue as well. So the phrase in the title is Intranet Redirect Detector. This is the name of a file in the Chromium source code, which is an open source project from Google. It's of course used to develop their Chrome browser, but it's also used in many other browsers, including all those listed here. And it seems that Chromium-based browsers have approximately 70% of the monthly usage share, according to the site in the footnote there. Chromium has this concept of an omnibox, which is the place where you type in both URLs, domain names, and search terms. And so Chromium needs to decide if what you're typing is in fact a URL, domain, or something else. And for things that look like domain names, it needs to know if it can trust the network to differentiate between non-existent and existent domain names, because it presents those slightly differently to the user. So one of the things that Chromium does is when it starts up, it sends these does these URL probe fetches to names that shouldn't exist, and figures out if the network is intercepting or redirecting those requests for non-existent domain names. So how this works is it constructs 3 random domain names, single label domain names, and they're put into HTTP requests. Each domain name is a random length between 7 and 15 characters. A few years ago, they were only using 10 character length strings, but that changed in 2014. Only uses letters A through Z, both uppercase and lowercase. And the expectation is that these are names that do not exist or should not exist, and the response should be some kind of failure. However, if any 2 of those 3 requests are successful and resolve to the same host, that host is stored as what they call the redirect origin. So this probing happens every time the browser starts up. It happens every time the software detects an IP address changes on an interface, and every time it detects a change in a DNS server configuration. And there's some examples at the bottom of the screen there. So this next sequence of slides sort of goes through how we, the method that we use to identify Chromium queries in our software, in our data, excuse me. So first we look at the response code, or whether the TLD exists in the root zone and the root server traffic. So you can see on the left there we have two bars labeled NXD and YXD. NXD, of course, is for NX domain, does not exist, and YXD is for names that do exist. And then on the right we have the count of how many queries there were for the leftmost label. So you can see it's about split. About half of the queries, the leftmost label occurred between 1 and 3 times. I should say also this is over a 24-hour period, all this data. So 1 to 3 times per 24 hours. And about half of them occurred 4 or more times per 24 hours. So we take that, and then for those names that occurred 1 to 3 times, we look at the length of the leftmost label. If it's 7 to 15 characters, then we'll proceed with the analysis. If it's not 7 to 15, then we don't further analyze those queries. And then we look at the pattern of, the composition of the string. If it matches the pattern where it's strictly uppercase and lowercase A to Z, then we say it matches the pattern, or for a smaller subset, it does not match. And so those that are 1 to 3 queries, 7 to 15 characters in length, and consist only of A to Z, that's our set of queries that are similar. They're like the queries that Chrome emits for its probing. So we call these as Chromium-like queries, or yeah. And then for a little bit further analysis, we break that down by how many labels were in the query name. Either they had a single label as originally formulated in the Chromium software, or maybe they have multiple labels. And that could be due to suffix search appending or other reasons. For those that had just were a single label, we then break it down by the length of the string, 7 to 15 characters, as you see here. And for those that comprise of multiple labels, we just break it down by how many labels there were, 2, 3, or 4 or more. So that's the technique. And as you might guess, this was from actual data. This particular one is from May 13th, 2020, from our traffic that we get for A root and J root. And as it turns out, about 45% of the queries match this pattern of being from Chromium. And if you look at the very end, you can see that the length distributions are pretty even. And we suspect that the cases where there's 2 or more labels, 2 or 3 labels, those are primarily due to suffix search appending. So this graph also shows the distribution of lengths of the first label strings. And this graph, of course, I have to admit, commits one of the sins of how to lie with graphics, and that the y-axis does not start at 0. But that's just to show that for most of these, they're very evenly distributed. The difference, of course, is 10 is much higher because, again, the older source code used 10 character strings always, and 7 is a little bit lower. We believe that's because with 7 character strings at the levels of traffic that we're seeing, there are some collisions, and those collisions drive up the query counts, and they sort of then fall off of the analysis here. So this technique is not by any means perfect in exactly identifying every query that comes from Chrome. There are a number of reasons or ways that there could be false negatives and false positives. There could be some names that match the pattern, but but aren't truly random. They're not. So for example, Duane's blog.unpopular site. That's my very unpopular blog, and it only gets 1 or 2 queries a day, and so it matches the pattern, but it's not truly random. It didn't originate with Chromium, so that could lead to an overestimation or an overcount. We know that there were these random names in the root traffic predating the Chromium feature. We know that from looking at old diddle data. And so, there's probably something else out there that's doing something similar, and that would lead to an overcount as well. Software that does retries and aggressive suffix searching could lead to extra queries, again, causing us to exceed the threshold, and that could lead to an undercount. The aggressive NSEC caching feature could also effectively lead to an undercount by blocking some of those queries from reaching root servers. And if you remember, Geoff Huston had a presentation last year that talked about how DNS has such a long memory, right? He sees lots of replayed queries. And so some of these that we're seeing also could be queries replayed, which, depending on the way that they're replayed, could lead to both undercount and overcount. So one interesting thing that we also wanted to show is, as it happens, in 2016, there was a diddle collection for when we changed the length of the ZSK in the root zone. And as it happened during that collection, there was a botnet attack, and that botnet traffic used pseudo-random prefixes, and so we captured some of that. And that's what the data looks like from that day. Over that 24-hour period, the attack didn't last the whole day, of course, but for that whole 24-hour period, if you look at the green area, you can see that unlike the previous one, here the multiple labels section is quite a bit bigger. And so even a real botnet attack is sort of dwarfed by the scale of the actual traffic coming out of Chromium, right? Here it's only the botnet traffic was 11%, whereas the remainder of the traffic matching the pattern was almost 20%, 19%. So we performed a longitudinal analysis of the Chromium queries using the diddle data, going back all the way to 2006 and up to 2019. There's unfortunately a little bit of a gap from 2014 to 2016 due to that data being unavailable because one of the OARC file servers is offline. But we did find the October 2016 data and sort of use that as a stand-in for that year. The 2017 to 2019 data was really difficult to analyze properly because of its size and constraints of the analysis server. So for example, the 2018 data, which was the last year that we could analyze in full, it took nearly a whole week to churn through that. And one thing to note, you'll see this on the next slide a little bit, the percentages vary significantly among root server identities. So for example, A root might have, for a given day, it might have 30% and B root might have 40% or something like that. So there is quite a big range between how the different identities perceive this traffic, I guess. At VeriSign, we have some data for A root and J root going back to 2015, and we include that as well. For the early years of that, we only had the NX domain data, so we sort of artificially adjusted it using the RSEC 002 data to bring that back in line with everything. So here's what this graph looks like. Sort of first, I'll point out the dashed line represents Chrome's market share over the years. And so you can see that obviously growing up and up. There's a spot where we highlight where this feature was introduced into the Chromium source code. That is the time in which it was first sort of put into the source code repository. Doesn't necessarily mean that was the time when it first saw use in users. We didn't try to figure out the release schedule and how prevalent the software was in different versions of Chrome, but that's the time when it was first put into the code repository. So this this green line, which has both a solid line and a shaded area, that represents the percentages from the diddle data over the years. And the shaded area represents the spread between root server identities. So you can see that spread is quite significant. The solid line in the middle represents the mean of all of those. There was, again, a bit of a gap, which a little bit hard to see here, but there's a gap between those years, 2014, 2015. And then for 2019, as I said, we couldn't analyze the whole data set, so we analyzed a subset of it using sampling, and that's included here. And it seems to line up pretty well, even though it was subsampled. I believe the sampling slightly overestimates the actual value, but certainly not as much as it varies from letter to letter. And then the purple line, which has a lot of points, show the analysis of the data that we have at VeriSign for A root and J root on a weekly basis. So there's one data point for every week there. And we were very happy to see that there's this sort of weird thing where in 2018 it sort of drops back down for some reason, and the VeriSign data confirms that as well. So the end, of course, the 2020 diddle data was too recent. We weren't able to analyze that, but we do have that for our own. And as you can see, it leaves us at about 50%. 50% of the traffic that we get at those servers, and presumably other servers as well, appears to be due to this Chromium feature. And due to the way those queries are formed and the way they look exactly like a pseudo-random subdomain attack. And anyone, I think, who was operating DNS infrastructure and 50% of their queries looked like this attack traffic, I think they would have reason to be concerned. So this leaves us with some open questions about all this. First, is the load that's being placed on the root servers for determining this intranet redirect, is it proportional to the problem case that Chromium is attempting to solve? We wonder what were the criteria used to determine that 3 queries was the right number of queries to make. Was it just a wild guess? Was there some research behind that? Would one query work maybe just as well? We also can't help but wonder if this technique would work equally as well under a separate domain, under a reserved TLD, or under a domain that's properly registered and owned by someone who can bear the burden of these queries. We wondered how common is this NX domain redirection or interception, and based on a sort of a quick analysis that we did using one of the built-in RIPE Atlas measurements, we see it in about 1% of RIPE Atlas probes that their queries appear to be intercepted, or their NX domain responses appear to be intercepted or redirected. Something we really wanted to do with this talk, but what didn't due to the sort of time constraints, were to further analyze the extent to which suffix search lists make this even worse. So if you have a recursive or a stub resolver with a sort of a even a moderate sized search list, you would expect to see these queries repeated with those suffixes appended. We wonder about technical solutions that can help mitigate this root pollution. As I hinted at before, Firefox does something similar, not quite for the same reason, but it does some probing. And in Firefox's case, they use second or third level domains that are owned and managed by Mozilla, I believe. And then things like aggressive NSEC caching and QNAME minimization and NXT cut probably, if more widely deployed, would maybe have an impact on the level of traffic that we see for this. So that's the presentation. Happy to take questions. This will be an exciting experiment to see how questions work here.
Okay, the way that questions work here is that you can ask questions in the Q&A channel, which you see at the bottom of the Zoom window, and either me or Jake will read them We've got several questions for you, Duane.
Okay.
Get stuck in. Okay, so first question from Warren Kumari. Do you have any idea why the distribution is different for different letters? Does this follow the normal difference, or is this more different than regular?
Yeah, thanks, Warren. I don't really know. We didn't fortunately investigate that. My guess would be that it's different, probably for the same reason that other things are different. There's that general traffic levels are different. I do know that due to the way that our analysis was designed, like if you looked at a longer period of data or more queries, then because of those thresholds, some of those thresholds would get exceeded for certain strings, and so they would sort of drop out. So certainly the amount of queries that you receive could affect the results in this, I guess.
Okay, next question is from Cricket Lou. Isn't such interception most common in captive portal setups? Seems like write probes wouldn't see those.
Yeah, that's a good question, Cricket. I don't know. I don't know the extent to which captive portals versus just implementing such a feature on a recursive name server. I don't know where the balance is on those two things. I don't think, though, that in Chromium's case, I don't think its purpose is to detect captive portals. I think its purpose is different. In Firefox, I think that is the purpose of their probes, is to detect the captive portals. But for Chromium, I don't think it's that.
Okay. Next question is from Greg Schulz. Speaking as a recursive server operator, should we, if we could, block or drop these queries?
Well, I don't know. I mean, I don't know how that would affect the way Chromium operates. But I think, if you were to implement something like, if you were able to implement something like aggressive NSEC caching, that would effectively block them. And maybe it would still work in a way that makes Chromium happy.
Okay, from Ruben's Cool, I would add to Warren's question whether in DITL other non-A root letters suffer differently, like F and L.
Yeah, I don't know off the top of my head. That's we could do a further analysis on why they are different, but we haven't done it at this time.
Peter van Dijk asks, what is the Firefox approach you mentioned?
So as I understand, Firefox emits queries. Again, I think it's to detect captive portals at startup. Maybe to redirect the user to a sign-in page or something like that. Whereas I think what Chromium is doing is something that it needs throughout its operation. Again, as users type things, it wants to present the typing differently to the user when it lands on something that's a real domain name versus not a domain name.
Okay, Hugo Salgado asks, are you aware of any data telemetry that Chrome people could have about this? I wonder if they can confirm that 1% of NX domain interception.
Yeah, that would be interesting. I don't know of such data or telemetry, but if they were willing to provide, what they know about the prevalence of this redirect interception, that would be very interesting.
Okay, Warren has a comment, that's Warren Kumari. I do not see how this would work under a reserved TLD or registered name. The whole point is to look up names which would not be blacklisted or whitelisted by operators of captive portals or redirectors. We've seen captive portal operators and redirector operators look for these sort of names and explicitly allow them.
Yeah, that is probably the crux of the issue, is whether if you had, as Warren says, specific TLDs or specific names under which this probing occurred, would they be blocked? Warren's probably in a better position than I am to say that is or is not happening. But that's maybe a future research area. I don't know.
Okay. one point, we have about 3 minutes left for questions, so I'm cutting the mic line now. So Johan got in there with the last question, and I'll press on. Comment from John Todd. Possibly another slight undercounting in one of the filters. The subset of does not match in the NXD area could actually include some Chrome generated results that are being forwarded by 0x20 enabled forwarders like Unbound, which turn random lowercase letters into uppercase in the queue name, making them not match the A to Z filter.
Yeah, John, I need to double check that. I think that I don't think that Chrome emits strings of all lowercase, for example. I think it has a mixed case, but I would need to double check that. You might be right about the OX20 stuff.
Okay. Benno Overander asks, do you have an estimate on the over-under count, or by the vast majority of Chromium queries, the over-under count is just noise?
Yeah, so in my opinion, the over-under count is sort of just noise because you know, the huge difference that we see from letter to letter sort of dwarfs any of these other sort of things about, you know, whether you count 4 queries or 3 queries or whatever. So I think if there's uncertainty, really, it's in that part. It's in the variance between letter to letter, and not whether, you know, Duane's unpopular blog site got counted or didn't get counted.
Okay, second question from Benno. What's the impact of these queries on root server operations?
I would say there's no impact in terms of them not being able to handle the load. But I do think it's important that we are aware that you know, half of the traffic is due to this. Certainly, there are you know, the root server operators bear some operational costs for needing to build systems that can handle the current scale, and say dropping that by half all of a sudden tomorrow probably wouldn't change a lot. But still, I think there's a mismatch of costs and benefits here.
Okay, Eric Zegast asks, have you seen any compensation or holes in query volume from large Anycast recursive providers that it seemed they already compensated for this extra load?
Eric, I guess you're asking, like, are they already blocking these somehow? If that's the question, we didn't look at individual addresses or recursive providers or ASs or anything like that.
Okay, question from Samine Tajalizdahub. Do you have any statistics of such an attack in the wild?
So certainly we have, for example, in that one diddle collection that I mentioned, there was an attack that whose queries look very much like this Chromium query, and other people have, you know, well documented pseudo-random subdomain attacks to their infrastructure, not just the root servers. We don't. Yeah, that's about the best I can do at this point, I guess.
Okay, comment from Giovanni Mura. In general, on selection of letters, resolvers tend to choose letters with lower RTT, but they balance diversity of name servers too. See paper resolvers in the wild.
Yeah, that's right. The ones that generally have lower latency probably tend to get more queries, and that can affect you know, the results in some of our techniques, because we're looking for popularity in queries, essentially.
Okay, last question from Johan Fricks. If someone were putting forth their own resolver with an alt route like handshake.org does, would you be seeing that traffic with this sample set? I think Eric Zegast already answered yes.
Well, I would have to say it depends. I mean, if it would depend if this alt root system or this recursive name server, how it was configured to, you know, again, to respond to things that don't exist. If it stops, if it looks in one place and stops, then no, we wouldn't see it. But if it gets a negative answer in one and decides, well, I'll check the other, then yeah, we would still see it.
All right, okay, thanks, Duane. There is one other question there, but I think we need to move on, and I'll direct that to you offline.
Okay, thank you.
Okay, thanks again. Okay, up next we have Suzanne Woolf from the Public Interest Registry, who is going to talk to us about DNSSEC in .org with a dash of COVID. Suzanne, are you ready?
Thank you, Dave. I will go ahead and get screen sharing spun up here. And nice to see all you fine people, even though I can't really see you. And you should be able to see the slide deck there. Welcome everybody. And as disappointing as it might be that we can't actually talk to each other in person, it's glad to be here. I do want to start by saying that this work is, my name is on it in this particular slide deck, but it's primarily me and Joe Abley at PIR. And I also want to acknowledge the folks at Affilius, our registry services provider that we've been working with on all of this, on the project as we've gone on. So in our first episode, in the long ago, .org was the first of the generic TLDs to be signed with DNSSEC. And that was a really long time ago, June 2009. In October, we signed with RSA SHA-1 and NSEC 3. A little later that year, RFC 5702 with SHA-256 was published. The following summer, the org zone was able to accept DSRR sets for child zones through EPP, which meant that second level operators could sign their zones. And then in July 2010, the root was signed, which meant that it was possible for .org zone holders to have a fully signed chain of trust back to the root trust anchor. We were real proud of this. We were and proud to have it be the first of the GTLDs that were signed and that it just worked. You know, we're infrastructure people. We like it when it just works. But part of the job is stability. Besides stability of the infrastructure is maintenance. You know, we should go back and review every once in a while and make sure that we're paying attention, see what's happened, see how the technology has changed, see how people's needs and expectations might have changed, and see if operational practice and experience, what can we do better? So we decided early this year that it was time to go back and review the signing parameters and the signing processes for .org and make sure that we could learn from experience and evolution and operational practice and try to figure out what we could do better. So at the last in-person OARC, I got up and did a lightning talk about refreshing the DNSSEC parameters in .org. We got a great response from that. We got researchers and other TLD operators getting in touch. They wanted to talk, they wanted to help, they wanted to do research on this opportunity to watch how DNSSEC, how the internet changed, how data might change, how the DNS might change as we changed parameters in DNSSEC. And then in March, everything, well, you know, PIR and Affilius, along with everybody else, closed their offices. Everybody sent to work from home. Non-essential travel canceled. So we had a pretty detailed plan of what we were trying to achieve, which we then had to sort of drop back a little bit and reconsider. First, we wanted of the factors that we identified that we wanted to address. .org had an enormous DNS key RR set, which Geoff Huston was making fun of us for. And quite honestly, we're always happy to give Geoff comedic material, but we trust him completely to continue to find comedic material without us, and it was somebody else's turn. The thing that got us originally thinking about evolving the parameters was that it looked like a good idea to revisit signing algorithm. What could we move to from algorithm 7? And we had signed .org originally with NSEC 3 for reasons that made sense at the time. People's feelings seem to have changed about zone walking, and the protections in NSEC 3 about zone walking are not necessarily what you'd want if you were concerned about it today. Opt-out makes aggressive negative caching difficult, and NSEC 3 is more complicated to provision. So let's revisit all of those things. Where we thought we could go was finish some incomplete KSK roles, review pre-publication parameters, do some other things in the lab with signer parameters, look at what algorithm we wanted to roll to. 8 was obviously easy. 13 for a comparable amount of effort would have been more fun. And we wanted to start lab testing to find the performance implications of 7 versus 8 or 13 for signing and for other maintenance of the zone. And we wanted to go to NSEC. We're pretty sure we're no longer concerned with the original reasons for NSEC 3, but with 10 million delegations, most of which are insecure, there was going to be a resource hit related to changing from NSEC 3 to NSEC. So let's do some more lab testing and find the performance implications of signing the NSEC and start reviewing the edge capacity forecast for memory footprint. Just figure out what resources were involved and assess the impact. And we had a pretty good idea how we wanted to go about it. We want, as part of our mission, we try to be as public as we can be about how we engage on these technical activities and decisions. We want to make sure that resolver operators are aware of our plans. We want to make sure that we're looking at anything interesting about the validator population and what the impact is going to be of rolling the algorithm, particularly depending on whether we go to 8 or 13. We don't know for sure. We think there possibly hasn't been a production TLD roll from NSEC 3 to NSEC, so we'll see about that. And we wanted to make sure that we had reached out to the operations folks and to researchers about our plans and about being able to gather data or share experience or take part in learning from this exercise and making sure we've learned what we could from the community. So we talked to Keith and Matt, and there's a mailing list, and we started talking about how we might contribute funds to help with the data collection, because more data, always good. Now, all of us that work on infrastructure are tremendously proud and humbled by being the degree to which people have been able to move their lives online when they had to. But of course, there are costs and there are things that are slower now and harder now and can't be, or even can't be done. So we got as far as strictly on the technical side of looking at discovering that the current signing platform in use for .org has unoptimized support for ECDSA. There's a new signing platform under development, but it's not fully cooked yet. So there's a technological constraint on signing and being able to move to 13. Any effort to address that, there's some challenges with the current situation with COVID-19. They're setting up a lab with new hardware, lots more difficult. Crossing borders to deal with systems issues, also more difficult. Changes to key management that involve people handling credentials, even if practical, not necessarily a good idea. And we really wanted to have this research partnership thread through all of our efforts, and universities all over the planet started closing down and sending everybody home. Courses suspended, campuses closed. People are really struggling, and bringing in new research is not necessarily going to be at the top of anybody's list. And in all fairness, as infrastructure people, everybody suddenly depends on the DNS even more than they used to, and this would be a particularly terrible time for anything to go wrong. So nothing that is going to have an operational impact is going to happen under current circumstances. It's just not how we roll. We picked the wrong week to quit drinking. So much for the second quarter of 2020. However, what can we do? We've got half the year left. We can review the relevant parameters and the existing signers, key pre-publication, signature lifetimes, the other things that we can look at modifying either to improve security or to improve manageability or both. We can test the performance implications of the roll to algorithm 8. We can test the robustness of the algorithm rollover in the current signer. And we can do a dry run in some smaller TLDs, and emphasis again that we take full precautions with any TLD as far as operational impact. But we do have a situation where a smaller TLD would be any issue would be easier to mitigate and would affect far fewer users. At some point, it becomes reasonable to do this. And we wanted to keep alive the communications and outreach and coordination efforts. So the current situation, we have been able to go a lot deeper on the capabilities of the existing signers. How much work is it really to sign with NSEC? If we can't go to algorithm 13 anytime soon, can we plan a sequence of algorithm roles? ZSK rollover policies and procedures, there's been a fair amount of experience with those things now. Let's go back and make sure that we have learned what we can from others' operational experience. We put together roadmaps with affiliates for whiteboard and lab work as soon as feasible. There are going to be things we're going to have to get people in the same room with a whiteboard and a bunch of machinery and just do. We don't know any better than anybody else does when travel is going to be possible again. So we're doing what we can remotely, but that's lower bandwidth. We are planning out very cautiously some changes in some smaller TLDs that affiliates operates. Again, full precautions, very careful with operational impact, but smaller TLDs are a reasonable next step. And we're trying to keep talking with people, trying to keep making sure that folks who do have experience or have ideas and want to try things, or just want to have ideas have ideas about what data would be interesting to have as we proceed down this path. So I'm seeing quite a few people in the participants list here. And again, the urge here is to reach out. You tell us what you'd like to see. There's a unique opportunity here, we think, to observe DNSSEC at scale and how to change. What is the impact of changes? What can we see? So if you have experience, interesting research questions, ideas about other things we could do, parameters we could review, changes we could consider, please talk to us. One of the things we're considering, and I do have the URL for the mailing list there, please sign up. We have also talked, if there's interest, if there's support, we can do a virtual meeting where we can start discussing some of these things. We would love to hear others' experience, and we would love to hear what data you think it would be interesting to have. We do want to do a feasibility, a more formal, rigorous feasibility study for a roll to algorithm 8. Admittedly, this is more incremental change than we were anticipating, but it does get us away from SHA-1, and it's a reasonable piece of work in that it does require testing and planning and documentation and procedure just as much as a larger change would. So it's a chance to experiment and demonstrate good practice and operational commitment. The other thing to keep in mind, again, with any kind of significant change to operational parameters, it's not often we get to look at contingency planning in quite the same way that we do right now. It's not an opportunity anybody wanted, but it's something we can learn from. In an ideal world, we'd still love to get the algorithm roll for .org and possibly reviewing some of the other parameters we've discussed. We'd still have to get this done in 2020. We see the opportunity for both the opportunity for people to study how the DNS reacts to changes like this, and to potential improvements in performance and manageability of the zone. So we'd like to get it done. With the concerns we've got, though, about stability and I don't know, you don't want to say nimbleness of the ability to respond to unforeseen challenges, we're prioritizing stability. We're prioritizing what we know. And it's always possible. We're going to we have to do a very thorough risk analysis, and it's entirely possible that the risk analysis will indicate that we're better off waiting. So we're trying to do what we can towards operational improvement and towards helping our research partners figure out what data would be interesting to have. So if you have thoughts on that, we do want to hear them. And if there are any questions, comments.
Thanks, Suzanne. We have got 4 questions, and in the time we have available, I don't think we can take any more, but I will work through those. First one is from Brian Dixon. When doing your assessment, one variable to consider would be, what if big player suddenly starts turning on DNSSEC for domains, i.e. delegations, e.g. 4% more, 40% more, does that change the calculus?
Can you repeat that? The beginning, just the beginning of the question, because you, as you know, I don't see the questions. If who turns on?
When doing your assessment, a thing to consider, what if a big player suddenly starts signing delegations under OARC?
Oh, okay, I see. Yeah, thank you. That is actually a good point. We have looked a little bit at, because this is one of the big changes between NSEC 3 and NSEC, is that NSEC 3 is actually much easier to provision given the amount of uptake, the number of child zones that are actually signed at when we started and at this time. So a big change in uptake would be significant. Thank you. Next.
Okay, yeah, next question, also from Brian Dixon. What about lab sharing agreements within DNS-OARC members? Would that help address some of the issues, or is that largely dependent on specific hardware from specific vendors?
We have been working with affiliates and their testing capacity, because they are, of course, closest to the production facilities we work with. But being able to discuss with other folks with lab setups would actually be welcome, and happy to hear from folks online in the mailing list or directly.
Okay, this is from George Michelson. What defines an algorithm role sequence? Do you mean some kind of state distinct from doing roll A to B, and then at a later date rolling B to C? Is this about maintaining visibility of algorithm A during the B to C transition? Why did you want to do that?
Well, it's not really what we want to do. And I'm personally not enthusiastic about it. The question assumes a little bit more than I think I intended to imply. A sequence of algorithm roles should be no different than having one and then having another. There should be no transitive properties there. But it's not inconceivable that there would be. So we are looking in detail at if there's any particular risk in doing multiple algorithm roles within a particular period of time, as opposed to doing one once and saying, okay, we can't do another one. It's a matter of where do we really want to go, and what are the constraints we're operating under at any given time as far as what we can move to from current state and in how many steps.
All right, okay, last question from Brian Summers. Regarding .org DNS keys 900-second TTL, can we make that longer? Recursive resolvers trim dependent signed RR sets to no more than their parent. 900 seconds means lots of .org lookups.
We can. The TTLs was actually one of the things, and it's on the slide, but I don't think I said anything about it. But TTLs are actually one of the things to look at as far as parameters we might want to revisit in view of, operational reality today as opposed to in 2009. So yeah, I think that's one of the things that's on the table. Thanks.
All right, thanks very much, Suzanne.
Thank you. And let me shut off sharing here.
Okay, next up is Wes Hardaker from ISI with a talk titled DNS Identity and Internet Naming for Experimentation and Research. Wes, are you ready? Oh, you're very ready.
I'm very ready. We're up and going, and thanks for reading off the long title because I didn't want to do it. We're really good at creating long acronyms at ISI, and a lot of that comes out of never being able to reuse an acronym. So we're going to talk a lot today about the project that we're sort of just starting up. It's an exciting one that we're hoping to get your participation in. So definitely stay tuned for the end where we can ask for your help. One quick thanks to the organizers of OARC for doing this virtually. I think that was a great undertaking to try and shift, and I hated the fact that my favorite one of my favorite conferences was going away. So thanks for running it. We were brainstorming one time of, well, what else, is DNS likely to see in the near future? What other things do we think, might be coming down the pipe? And it seems like it's just never ending, right? So in a minute, we came up with a whole list of questions of, well, how does DNS work if it was entirely over V6 or TCP or QUIC? And then, within 5 minutes, we'd expanded that question list to quite a bit more, and then quite a bit more. And, the reality is the internet's landscape keeps changing, and DNS is always going to have to keep up with the current trends, whether it's privacy related shifts or infrastructure related shifts or Chrome, based queries and things like that. It's just constantly changing. So we created a program that we got funded from the NSF, which I'll talk about in a minute, for trying to create a new testbed to actually sort of help battle this ossification problem that exists between the ability for people to do research and actually deploy stuff in sort of a tech transfer and safe way. So we are doing that with a new testbed that we're hoping to help drive some research efforts. And I'm going to talk about that architectural overview of that testbed and then our plans and our timeline. So why Diner, as we're calling it? Originally the DNS was literally an experiment. It was designed to replace static host files. I'm sure most of you have edited etc hosts at some point in your life. But now the world sort of relies on it being perfect, right? You can't break the DNS anymore. You can at the fringes, who cares about the fringes? Well, they don't like to have it broken, but breaking stuff centrally is just non-possible. So it's very hard to roll out changes. And so what we thought was maybe we could actually keep doing academic research and then slowly push it out by enabling a parallel path so that we can sort of study changes to real world infrastructure without actually letting it go out the door operationally. And I'll explain that a bit more in a second. And this, of course, has led to, DNS 2.0 will never happen because we're so grounded in the DNS being operational that we can't change it anymore. Whether or not 2.0 is a good idea, I'll leave to the crowd. So Diner is a 3-year funded NSF research project, and the whole goal was to create an academically accessible collaborative infrastructure where researchers could get together and brainstorm and come up with new projects and be able to do measurement. A number of you supplied us with letters of collaboration saying that you were looking forward to this project coming online. We greatly appreciate that, and thank you publicly to everybody that did write us a letter, because I think you helped us get this project funded. And again, the goal is to join sort of research and operational communities and do stuff in a safe manner. So to do this, we are building on the b.rootservers.net infrastructure, as well as pulling in resolvers and authoritative servers eventually. And all of that infrastructure today on a large scale production interface on a particular site typically looks like this. You have a bunch of incoming requests, you have some sort of magic load balancing, then you go to a bunch of production nodes, and they actually send out the outgoing responses one way or another. So this is a very common architecture. What we wanted to add to it in our project was the ability to actually mirror the requests coming in, send it out through a doubler, and send it to an identical production node pair and an experiment node pair, so that you could run some software on the production node and some software on the experimental node, and then actually compare the results. Were all of the results equal? Were they all valid? Or did they change in the way that you expected? So that you could actually get some validation that your experimental technique was not going to break the internet. So to do this, we were going to design a couple of research analysis tools that help do that comparison, that validation as well. And then we can also compare it with the real production nodes output. Now, of course, for experimentation, you always want replayability as well. So we're adding a few other blocks to this that allow a replay set to be played in sort of from the left-hand side. So once you find some interesting traffic, and we have a bunch of curated interesting traffic that contain interesting attacks and things like that to be in the past. But we can refeed things, so you can adjust your software, redeploy it, rerun the same experiment, or you can start pulling in live traffic again. All of that can be optionally mutated. So this is how you might convert all the UDP requests to TCP in your experiment or something like that. And these are all housed in different physical nodes, and we'll come back to that a little bit more. And then finally, one of the huge goals is to also do data capture and curation, to be able to collect all of the data from the experiments that you run, archive it, and then release it publicly if you find interesting data sets, you know, in the experiments you're running, or this is how we release data too, including to OARC. And one of our goals is to collaborate more with OARC and possibly produce, you know, interesting data sets, and probably of a smaller size than Diddle, to OARC if they want it, of course, or to other venues. So here's our plan and timeline for how we're actually going to make all of this happen. We're going to clone a BRoot production system as a parallel test system. We've actually done that. The project's only 6 months old, but we have a number of important check marks stamped in the front. Simultaneous monitoring of a production versus a test set. We've actually done that, and I'll explain more in a minute with a new diagram of our current architecture. And, you know, there's a lot of other things that we want to do. We need to, you know, install the Steam replay and performance tools. That's actually almost done. So you can run DNSPerf, or we have some replay technology for replaying traces already ready to go. It's just not installed yet. And then long term, there's a huge, you know, list of things that we want to do, including mutating queries, like I talked about, and the verification engine and things like that, as well as being able to bring your own DNS, right? So right now we have some resolvers that we hope to mirror, and we have some, you know, zones of our own that we hope to be able to mirror and to play as well. Right now, the only thing that we have is the root traffic, but the goal is to bring in an entire ecosystem. When's the last time you were on a test bed that had all levels of the DNS hierarchy available to compare and to test? Again, the real world, you know, production versus comparison engine, that'll start off very simple, you know, are your answers correct and legitimate, and then diving down into, you know, a much more greater packet depth analysis to determine, you know, whether your packets are not just legitimate, but were they what you expected in your answers for your experimental hardware or software. We also expect you to be able to bring in your own hardware. If you have, you know, a commercial off-the-shelf type system that you're developing and want to see how it will perform against, you know, production services, this is the time to do it. And then finally, of course, we'll have a console for doing project management, experimentation. Right now, we don't have a whole lot of infrastructure for actually managing users and running, you know, the time sharing of the infrastructure, but that will come as well. So this is actually what we have running today. It's slightly different than the diagrams we had below. We decided, you know, we actually had stuff available that we could stand up something really quickly and immediately, which we're very excited to announce is available today. You know, the top is still the same. Really the one difference is, rather than taking and duplicating everything coming into the site, we're only duplicating one production node, and we have an experimental node that exactly mirrors that. And that can be, we saw the query mutator, which is not currently doing much, but will in the future, and then a research analysis toast. But the important point is that we actually have this up and running. The experimental node in the bottom is functionally hardware equivalent to one of the production nodes, so that you can actually make, you can race, right? You can race our infrastructure against yours. So plans for, you know, short term and long term, you know, one of the things that we are going to do on July 22nd, we're announcing it here first. You guys win in terms of, we haven't announced it anywhere else yet. We're going to hold a virtual workshop to discuss future needs and plans, not just of this infrastructure, but just DNS research in the whole, and other infrastructure as well. What do we need collectively to, you know, push forward research in naming and identification? We want to work closely with some early adopters, more on that in a second. And in the long term, you know, we want to sort of build up a larger bed of projects that people can sort of start brainstorming about and thinking about, and coming to both this infrastructure as well as others too. That includes OARC. It includes, you know, some of the Deter-like test beds that allow you to build, you know, whatever you want in a virtual environment. And then hold annual workshops for collaborating to sort of see what we can push forward. We did run a first experiment, so we wanted to demonstrate that the mirrored approach was actually up and running and working. So the production systems, which are the orange lines, are running ISC's bind, and the Diner backend it was running, which is the experiment, we were running not. You can see that the loads on the bottom not wins by a long shot, but we are running a older version of bind, so the newer version of bind we haven't tested yet. Which is supposedly significantly faster based on the presentation at the last OARC. Note that no TCP is being passed. That's one of the fill-in blobs in the mutator, is to be able to reconstruct TCP queries. So really it's not a totally fair comparison, because NOT's only getting UDP and bind is getting TCP as well. But it at least shows that, and we can actually hand this graphing set to you, so you can actually watch both your experiment and the production system live at the same time. This will be a publicly, or a research available graph. So please join us. We really want your feedback, not only on is this a good idea or not, but, oh, bad timing. We want your feedback on whether this is a good idea or not. We want your feedback on what you need, what is it missing, what can we add to this to make it a better platform for you? How can we help collaborate with other organizations like OARC? And what do we need to promote, DNS naming and research? So we're seeking a few early adopters. If you're interested in participating, we're only going to take 1 or 2, and people that or organizations that we know have a good relationship with, and then we'll build it and open it more widely in the future. And the one bullet I added to this deck that is not in the public release deck, sorry about that, was actually the website down on the bottom, which is ant.isi.edu, which is the Ant Lab, and then the project is Diner with 2 I's, so D-I-I-N-E-R. And if you look at that, that will have a link to our upcoming event where you can register to submit abstracts for our talk on July 22nd, our discussion on July 22nd, and we'd love to hear from you. Are there any questions?
Okay, yeah, we've got one question from Peter Lexis. Is DNS over not UDP and TCP planned? So, e.g., TLS and quick experiments can be done, or is this purely about queries and answers?
Well, it's up to everybody that wants to run an experiment to bring, what they plan and run it. So this not experiment was just what I wanted to install. The power of this architecture is that we can give you the box to run whatever you want. If you want to run one of the kernel bypassing, modes for a name server to test it under real loads, we have the ability to do that for you. So we have experiments we want to do, and that includes running not, includes running things with TLS and stuff, but we hope that other people will bring experiments that they want to do. We don't have any production DO services yet, but there's always a long-standing question, can we run DO or authoritative DNS over DO? And hopefully this infrastructure can help somebody answer that question. Whoops.
Okay, we've got 2 more questions. I'm going to close the mic line there because we're running a bit behind. The first of those is from Robert Edmonds. Is your load balancer doubler hardware or software?
Well, in theory, it shouldn't matter. In Beaver's case, it's software based, but note that the existing infrastructure actually mirrors a real what the production backend would get at the same time. So there's not load balancing in front of the experimentation at the moment.
Okay, comment from Hazel Smith. I'm really glad that someone is putting together a realistic testbed environment, and I hope it works out. Thanks.
Oh, thank you very much. I appreciate the feedback. And again, anybody else, please do send us mail if you're interested in working with us.
Okay, and last question from Lars Johan Lehmann. Have you thought about data integrity issues when sharing the platform with others?
Yes, we have. We have a whole, I didn't have enough room in the slides to put in our list of how to do anonymization and safety, as well as, paperwork that needs to be signed for, standard stuff, but it's sort of very similar to DNS-OARC in terms of we already have an existing sharing infrastructure set up to handle those types of questions. So we have various levels of anonymization and things like that will be taking place.
All right, okay, thanks very much, Wes. At this point, I will step back and hand over the chair to Jake Zach, fellow member of the program committee, and he can take it from here. Jake.
Thank you, Dave. Our next presentation is from Sebastian Castro at Internet NZ, or Internet NZ, from Lockdown and Back, a DNS data story. Sebastian?
Good morning. I hope you can hear me. And we'll go into sharing screen mode now.
Yep, we can see you.
And I think we're good. So, good morning, everyone from the future. Here is Wednesday already. Cheers for coffee. And I'd like to tell you a story of COVID, lockdown, and DNS data analysis. My name is Sebastian Castro. I'm the chief scientist at Intranet, and we run the .NZ registry for New Zealand. So we are doing this OARC 32 online because we couldn't get together in one place, right? We all know that, and I miss you, seeing every one of you and having this conversation face to face. And the situation is because COVID-19. So this is a COVID-19 story, but with DNS. One of the advantages we have at Intranet is that we have a platform where we store all the DNS traffic for it since 2012. All the traffic we handle, which covers most of all New Zealand, and also one of our providers, which is Cyber. Thank you very much, guys, for making our life easier. And because we have that data since 2012, we can go and do all kind of historical analysis. Recently, we ditched our very old Hadoop cluster and moved everything to AWS, and we started using Entrada from SIDN. Thank you, SIDN. Martin, if you're online, for doing this DNS traffic processing. So a very streamlined. We made all these changes in the last 6 to 9 months. So having our traffic handy, we can do all kind of discoveries in the same way others do. And we were interested in answering the question of how the different stages of the New Zealand government response to COVID change DNS traffic patterns for .NZ domain names. Just to give you a hint, in case you haven't been following the news, back in 28th of February, we started sort of discussing internally what is going to be the response from the government about COVID-19. And you can see that's the time of the first case. And by March, there were changes to the way the whole country operates. And probably if you haven't heard in the news, New Zealand is now considered a COVID-free country. We don't have any active cases. We don't have any new cases in almost 3 weeks by now. So it seems like, oh, we are sort of over this nightmare. So the New Zealand government introduced the system of alerts, 1 to 4, where level 4 or lockdown, basically everyone needs to stay at home. Only one person is allowed to go and leave the house just to get medicine and food. So there's no people going around. There are no restaurant or shops open, anything. So life is really restricted. Level 3, basically the aim is to restrict. So socializing is allowed, but to a minimum. You can go and do shopping. There are no mass gatherings. In level 2, socializing is allowed. You can travel domestically, and some of the restrictions are lifted. And level 1 is what we call prepared. So there are no restrictions on physical distancing or gatherings, and we moved to that level 2 days ago. Unfortunately, I didn't have time to go and update the data to cover for level 1, but the story is still reasonably good. So for this presentation, we analyzed the traffic for .NZ between March 9 and May 31st. It's traffic from all over the world. but we focus on New Zealand traffic originated from New Zealand because it shows the clear pattern. We focus our attention on certain domain names that everyone knows they are related to certain activities. And then we take our magnifying glass to a very specific domain name related to the pandemic. So the overall picture is that this is by weeks. This is traffic by weeks. We get between 4 and 5 billion queries per week. At a global level, this doesn't change much. You can see up and down, so there's not a clear pattern. So let's go for black, nothing very interesting. But if we focus our view into only traffic generated from New Zealand, we can see activity start to ramp up from 9th of March and keeps going up until sort of normalizes, but it never goes back to the same level as before. I can show you sort of the trend on a daily and different weeks, and it's sort of regular. So follow the same pattern, except on specific days like ANZAC, which is a holiday which was observed on a Monday in April. Also, we have the Easter Monday, so reduced activity. We have Good Friday, and we have one specific point in between that people were sending a lot of traffic, what is called a domain crawl, so discovering domain names that are active in the registry using the DNS. Everything else looks more or less the same across weeks. So if we put colors to the previous visualization and align them with the different states of levels, you can go and start seeing the pattern. So our baseline in black, so the first 2 weeks of March, look more or less the same, but once level 4 was implemented, we start seeing increments of 10 to 20% of traffic on different weeks, on consecutive weeks, except on the 13th of April and 24th of April that have holidays. So once we go back to the 27th of April, you can see the ramp up compared to the rest. So we keep growing on level 4 and on level 3. And when we move into level 2, things start to decrease. So what you see in terms of growth, so the number on top of each bar is how much the traffic grew compared to the baseline, which is in the 9th of March. So why those changes? So basically, with everyone locked in their houses, they have to move into online activities, right? They cannot do any shopping, for example, but they can go and do streaming or learning or following information from the government, etc. We also have this is data from Chorus. So Chorus builds and manages the underlying fiber and copper infrastructure in the country. So ISPs in the country, they basically go and buy access to the infrastructure from Chorus. And you can see the different patterns of how the traffic pre-COVID look down, and then how it spikes up or during a level 4 and level 3. So this is in terms of pure bytes, and you can see on the x-axis, this is in terms of terabytes per second on the network. So there is a correlation between what we're seeing in the DNS and in the bytes, in the pipes. So we move into taking a look how different categories of domain names of different categories of human activity change across different days. So we picked a few that we knew they would sort of work. So banks, government sites, not all of them, but sort of the main ones, especially because the response of the government was, okay, we're going to give you some help, but you need to go and fill out a form or check information about this program or this other program on our government site, retail sites, so not shopping online, streaming, supermarkets, and travel sites. And we bundled all them together. And we start analyzing from the same date. So you can see the trend on different level alerts, and you can see the changes. So travel sites, they basically sunk at the start of level 4. So with all flights canceled, travel restrictions in place, so basically the travel sites lost most of the traffic. There's only one that keep things going alive, which is a local air carrier. You can see the trend for retail. So retail took a slump, but then when we move to level 3, people can go and do contactless shopping. So can go online, buy stuff, and then go and pick it up from the shop or get it delivered by courier. So they saw a spike when things moved to level 3. Government activity, there's a lot of activity related to government. So go and check information about what we're doing to sort of support you during these times. And a bunch of them, different programs, everyone going online and filling up forms to get government subsidies and help. Banks, a streaming platform. So we're talking about local streaming platforms. So this doesn't count Netflix. Netflix uses a .com domain name, but local streaming platform, a steady growth on DNS activity. And then when we start things normalizing, they go down. So now we move the story to a very specific domain name that was created by the government in order to go and handle all the information about the pandemic. It's the COVID-19 govt.nz domain name. And we took a look at this, the traffic by hour. This is what you can see here. So you can see clearly daily patterns, a spike in the middle of the day, less activity on the weekends compared to weeks, and some specific extra activity on the week of the 23rd, which was the start of level 4. So with all the graphic is intentionally very noisy, but there is a hidden pattern in there, and I'm going to show you shortly, which is what time of the day is that domain name more active. And you can see it's 1 p.m. New Zealand time, then followed by 2 p.m. and then followed by 4 p.m. And so I know the answer, and I know my colleagues are in the streaming know the answer, but I like to introduce to the DNS-OARC community, Dr. Ashley Bloomfield. He is the General Director of Health and has been the face of the government response to COVID-19. So every 1 p.m. Of every day during the lockdown, he will do a press conference. Will he report the number of new cases, number of tests done, number of deaths, number of people in ICU, and all the information we needed to know about the COVID-19 and the response from the government. So most of the press conferences are 1 p.m., except when we have to engage with the Prime Minister, in which case will be at 4 p.m., which is the other peak. So, and all the information will be published to the covid19.govt.nz. So it seems New Zealanders were very keen on having that information at hand. So as conclusion of this exploration, the life of New Zealanders changed drastically during this lockdown. It was a big push to go and change the way we do things. We also because this is DNS-OARC, we didn't want to include information about registrations, but we have a spike of registrations, people going and setting up online shops and selling food with contactless delivery. So it was a big shakeup to sort of the economy and every aspect of our lives, but we adapted quickly. This situation will carry on for months to come, but I'm pretty sure we will continue to adapt, and we can keep taking a look at this. And many governments have used the term, this is introduction of new normal, and it seems for us it was definitely a new normal. And we're seeing more and more online activities and more people interested on picking up and moving. Okay, I can do better business if I adopt the use of the internet. So that's the presentation. I forgot to add the thanks. I appreciate your time, and I'm happy to take questions first, and also I'm happy to be the opening act for Geoff. So New Zealand opening the act for Australia, NAPD.
Thank you very much, Sebastian. We have a question. I also have a question on my own, if I may. I'm just quite jealous of your domain classification grouping into the various sectors. I don't know if you can give me any details on how you do that, or if we could touch base offline to get that information.
So well, that classification is was a dirty trick of, okay, we should go and explore these categories and what domain names we know in those categories. So it was a quick and dirty trick. But funnily enough, we have a methodology of using web content and machine learning to categorize different domain names on industry activities. So we have categorization for domain names for manufacturing and retail and professional services and that kind of stuff, but we haven't refreshed that in a long time. But we know how, so just we need the human power to go and do it again and regularly.
Perfect, okay. A live question from Calvin Brown. Just to be clear, this was all authoritative traffic?
That's correct, Calvin. Thank you for your question. It's all authoritative traffic for .NZ.
And George Michelson asks, does Uber Eats do a yourbusiness.uber.com form? Because you might be able to correlate into lockdown staging when order in became legal again. The selling domain post-COVID clearouts of home junk.
So that's really interesting question, because so Uber Eats has presence in New Zealand, but it's not the preferred method. So New Zealand shops find Uber Eats to have predatory practices. So they pick a different provider, which is called Deliver Easy, if I recall correctly. We didn't have time to go and take a look how the activity of that domain name changed. But when the contactless pickup of food and delivery of food change, we know a bunch of those sites basically collapsed because they couldn't cope with the load. So I'm pretty sure there is evidence in the DNS of that.
All right, and follow-up questions from George Michelson. Did you notice a shift in resolvers from small and medium enterprises and businesses to the ISP for work from home people?
So we have some level of classification of ISP resolvers, but we don't have a classification of small businesses in order to go and do that analysis of shift of traffic. That's something we would like to do at some point in order to keep an eye how things are shifting, but we don't have an answer for that now. Sorry, George.
Okay, it looks like that's the end of the questions for Sebastian. Thank you very much, Sebastian. All right, next up is Geoff Huston at a PNIC. presenting DNS Stalking 2020.
Thanks for that, Jake. Let me find a screen to share. Right, thanks a lot. Good morning, all. I must admit, my thanks to the PC for putting me on last. The time is currently 6:30 in the morning, and I now feel, you know, awake, which is always a good thing. This is actually a talk that I think I may have referred to a few times in the past, but we actually tried to do a more detailed study about what's in the DNS queries that we've been looking at. Because to some extent, the DNS is not just about now. There's an awful lot of other queries that float around the DNS. And we thought we might want to start looking at that. Why? Because, like Sebastian has said, the DNS reflects what we do. And you can clearly see work from home. You can clearly see government broadcasts about COVID. You can clearly see Uber Eats and all other kinds of aspects of user behavior. The DNS is indeed, I think, possibly the best reflection of what we do over any other analytic tool. I mean, this stuff is 2020 vision. So I'm not the only person to be interested in this, and neither are you. Everything starts with a call to the DNS, and a real-time stream of DNS queries. If you get closer and closer to a user, the detailed profile of the user is trivial. Do we have any evidence of this? Well, not clearly. And part of the reason is that you know, the various folk who do data mining and data analytics generally don't disclose their sources and make it open source. You know, I can't say I blame them, but you know, it would be interesting to peek over their shoulder. But I'm kind of interested in something that we can look at, which is actually digital stalking or DNS stalking. Do we see queries being replayed? And if we do, what's the extent of replaying that's happening in the DNS? Does the DNS ever forget a query? Now, this all starts with a number of suppositions that are, I suppose, completely artificial in the normal course of events. But it sort of echoes back to Duane's talk about what Chrome is doing. What if I gave you an absolutely unique name to resolve? But unlike Chrome, it's going to have an answer. So aggressive NSEC caching won't work in this case. The name never existed before. It'll never be used again. And it includes, encoded quite clearly actually in the name, the time when the name was created. So this is a one-time pad name. It just only exists once. Now, because it only exists once, and there is an answer, then I should be able to defeat caching. As the authoritative server for that name, I should see everyone's efforts to resolve it at least the first time. After that, caching might take over, but I should see you. If I gave the name to you, my authoritative server should see you. And because it's a one-time use, I should never see that name again. Now, there are some issues with timeouts, with a certain amount of noise in the DNS and retimers. There's a certain amount of aggressive search for an answer. And sometimes yes actually releases 3 or 4 queries. That's okay. But they should be bunched in time. And once that time has passed, I should never, ever, ever see that query again. Sounds like an absolutely fine theory. And like all theories, it's bullshit. So let's just sort of look at the mechanics of this. What we actually use, and many of you are familiar with this these days, is for almost 10 years now, we've been using Google's advertising platform to actually distribute a measurement system. The ad contains some HTML5, and the HTML5 does what everybody else does 24 hours a day all over the world. it gets URLs. And of course, a URL is a DNS query followed by an HTTPS query, generally. So what if we actually take that DNS query label and almost treat it like microcode? Treat it like not only a set of instructions, but some data as well. And so this is a typical query. What can we learn from that? Well, a number of things. The 06S says this only has an HTML that is in v6. If you try in v4, it won't work. The letter S says it's DNSSEC signed, which is instructions to our servers to craft a response in HTML that goes direct the user to a DNSSEC signed v6 only answer. But if you move a little further, that field with a U, we use UUIDs. And while that's not a huge amount of entropy, it's certainly enough to make sure that each ID field is used once and only once. I know where you are because you came to me to get the ad loaded with your IP address. So we use a geolocation database and code you up by country. Interestingly, the next field is the time this ad was created. So I know when this ad was made. And for certain matching with v4 and v6, what we actually do is take the original IPv4 address and fold it back in the query. So if you use v6 to query our servers, we know who you were originally by your v4 address, which triggered all this. So in this case, the query was at 10.0.0.1. Obviously, this is an artificial query. Now, the time is useful because all of a sudden, that time tells us the difference between when the original authoritative server saw the first query versus any requery events. So let's have a look at this. These are daily totals. And what we've done here, I should mention, by the way, I forgot to say, this is joint work with Joao Damas, who works with me at APNIC. And I just wanted to note him now. I'm sorry, I forgot at the start of this. Daily totals of queries. We get approximately 200 million real-time queries a day. By real-time, I mean within 30 seconds of the ad being created. And that's that purple line on those daily counts. We put in around 8 to 15 million events per day, and each event, each ad, actually generates somewhere between 10 to 15 DNS queries normally. So that's why we see a far higher sort of inside 30-second query rate of approximately 200 million a day. But the green is bizarre because these are older than 30 seconds. Don't know how old at this point, but they're older. And some days it far exceeds the normal query rate. A couple of days there, it was up to 550 million queries on that particular day. This period, by the way, spans from the start of, the middle of 2019 until a couple of days ago. So it's basically 1 year of queries. Over on the right, let's look at the ratio of zombies to normal. And half of the time, it's around 8% of queries. 8% of queries are sort of old, but there are days when the query rate goes up to 60 to 70% of the queries we received on that day were all old. And in fact, we're provisioning our system, not for the experimental load, but for the zombie loads. We are completely overrun by these old zombies. So now let's drill in a lot deeper. This is every second, and it's every second since the 1st of January 2020. And what you actually see is sort of an echo of what we're seeing at the day level, that we see rapid trapping zombies that do absolutely high levels of bursts, over 10,000 per second. And this is a log scale on the right. So these are phenomenally high peaks where we think it's replay zombies. So DNS query logs are generated, of course, everyone does it, but the replay is done over high-speed equipment at absolutely high-speed rates, as fast as the equipment will go. And then the bottom profile is the run-of-the-mill, the stuff that just is closer to the real experiment generation time. So it appears to be tracking in close to real time. And the rates of that are, of course, a lot lower. So we're getting these sort of two phases of zombies, the high volume, high speed replay zombies, and the background, almost cosmic radiation background noise of just run-of-the-mill zombies that happen close to real user rate. So let's look at it a different way by actually taking all of the queries in that period, start of January until now, and look at the difference, the age rate. How old were these zombies? So there's the first number, 350 million, are incredibly close to real-time stalking. So this, the bottom scale is in months. The first peak is there's a huge amount of stalking, very, very close to the first real-time event. But there's another peak, and that occurs at around 9 months old. What's so special about 9 months? I have no idea. And then there's an even spookier query peak between 2 years and 4 years old. The query volume rises again. And we're seeing a significant volume of well-aged vintage queries, queries that have spent some time in the cellar and come back up again because they're now fully mature and evidently very tasty. And there are a huge amount of them spread across that period of 2 to 4 years old. Once we go older than 5 years, at the end of this graph, it trails off again. So there seems to be, a bit like wine being cellared, an optimal time to put DNS queries down in the cellar and then bring them back up again to see if they're still relevant. Why? I have no idea. What's so good about 3-year-old queries? No idea. That initial peak in the first 24 hours, there's a massive peak just after the 30-second timer goes off. So in that first hour, it's huge. It could be an echo of a query just going through a relatively baroque or intertwined set of resolvers, load distributors that act as load amplifiers. There's all kinds of pathologies in the DNS that obviously don't work properly from time to time. And that's that peak in the first hour. After that, it's a relatively linear drop-off for the rest of the day. And so as the day ages, the number of zombie queries dries up a bit. But these are still enormously big over that period. The scale is in tens of millions. So it's between 10 to 100 million queries per hour as a drop-off over that first 24 hours. So is this just a couple of interesting sort of query sets that get hammered? Or is this more general? What's the repeat rate? So what I'm looking at now is the number of repeat queries, the number of times this experiment was beaten up and used. And the purple is the initial query, the green is the zombie queries. And the distributions are much the same. 80% of the experiments generated 4 or fewer queries in the first 30 seconds. 78% generated 4 or fewer zombie queries. So most of the time, the distributions are much the same. There are some outliers, and they deserve special congratulations. Someone managed to query us 117,000 times in 30 seconds. Whoever did that obviously is overachieving on their KPIs. And one zombie name that was queried 2.1 million times over 150 days. And again, you know, if you're doing this for money, good on you, you really overachieved. If you weren't, this is incredibly insane. This is also a long tail distribution. Rather than looking at experiments, let's look at individual queries and look at their query type as well. And what you find now is that 1/3 of all queries that are zombies have a repeat sequence of between 10,000 and 2 million repeats over 150 days. So once you get lifted into the zombie set, a third of the time, you're going to be hammering that bottom scale there from 0 to 100,000. It just keeps on going. So there is an extraordinary high repetition count. Who's doing it? Google handles queries indirectly for about 40% of the world's users, either as their first preference or as a second preference resolver. And so it's kind of unsurprising to some extent that the folk who are stalking, the stalkers, Google's very, very, very high on that list. Head and shoulders higher than everyone else. The rest generally reflect large user populations. So China, Reliance Jio, Idea Cellular, Claro, these are all massive ISP networks. But Ameritech isn't. Cloudflare is also pretty high on this list with zombies. Don't forget, these aren't real queries. These are the zombies. And so what we're actually finding is there are a couple of anomalies where their zombie query rate is actually far, far higher than their user population. I'm not exactly sure why Algeria is on this list, but you know, well done guys. Whatever you're doing, you must be very good at it. But let's add another piece of data here just to see what's going on. This is the average delay between the original event and the query in the zombie area. So Google, the average delay time is 3 years. So for some reason, we're getting this extraordinary amount of queries of 3-year-old names coming in through Google. I have no idea why. The large ISP networks, China Unicom, Reliance, Idea, Claro, Vodafone, Proxad, etc., very low query delays. So it seems to be an echoing of the original ISP resolver system that somehow is putting out queries over the next day. Ameritech, though, is an anomaly. Amazon's an anomaly. And oddly enough, the ISP network in Greece is an anomaly. And these are playing back extremely old queries. So let's narrow the field, because while the old queries are fascinating, those recent ones really, really, really sort of annoy me. Let's just look at one day and limit the zombie filter to only look at queries that are newer than one day. In other words, only look at 24 hours. And so while there's a certain amount of log replay, I don't think log replay is a near real-time thing. I think it's actually query capture and replay. These are the stalkers that are doing it in real time. So which ISPs have the highest ratio of near real-time zombies to experiments? So top of the list is someone in Hong Kong. We only put in an ad 20 times in one day, but we had 187 zombie queries. What an achievement, 90% zombie rate. You can read as well as I can, but they are actually a rather bizarre collection of countries and of ISPs. It's not quite big user ISPs, although China Telecom Guangdong is certainly right up there with a 50% rate. But equally, there are service providers and clouds like Tencent, and there are enterprises like PwC. We're actually finding the query bounce back and coming back relatively quickly. And just if you're wondering, down at the bottom is Ameritech. So yes, Ameritech folk are being watched relatively intensively. Where are they? Where are these stalked users? So instead of doing it by origin AS, let's look at it by country. And again, what an odd list. I'm like, Saudi Arabia, maybe. Japan, China, well, that's no surprise. But there's certainly some surprising folk in there, as well as some not so surprising folk in the number of zombies that are coming in per country. And last but not least, what are the resolver addresses that are doing this near real-time querying for zombies? And again, what you see is China, and India and our friends in Algeria tend to dominate this. Now, in some ways, this is a rather odd collection because the way load balancers and query farms work these days, these individual addresses don't really mean much, and maybe I should have grouped them by origin AS. But certainly what you're seeing there is a small number of resolvers are pushing through a dramatically large number of real-time zombies. And so the next thing, who's asking, again, the query count for each zombie? So this is a distribution, it's a cumulative distribution with a log scale. So what we're seeing inside this data is that 90% of queries, 90% of all the experiments we made had at least one zombie. But interestingly, 50% of these experiments attracted 10 or more retreated zombie queries. And of course, someone really did manage to win the prize, that inside this one-day period, they queried us 82,061 times. Well done. So my time is up. I just wanted to sort of make the comment that this is a tiny glimpse into a larger picture of log capture and replay. And I know there are various reasons why folk do this. Some of them quite noble and reasonable to understand how the DNS works. Some of them slightly more nefarious, I guess, into actually looking at, can we actually understand what users do from the DNS queries they make? And of course, the clear answer is, of course you can. And I'm not the first one to have figured that out, and certainly by no means the last. And by this query replay logs, there is a huge amount of capture and replay activity. The question that I would wonder about the larger DNS is how much of the DNS is real? How much reflects real-time queries? And how much of the load that we're seeing, a bit like the 50% load on some of the root servers, how much of the load we are seeing is actually an artifact of non-real-time behavior into the DNS? It's almost chaotic complexity being introduced by folk that think that queries are free. And the query pattern reflects a whole bunch of different motivations, not just the original thing of a real-time translation of name to address. So with that, I'm done, and we have 5 minutes left for questions. Thank you.
Thank you, Geoff. Our first question is from Robert Edmonds. Have you considered collaborating with researchers who work on browser extensions that leak browsing history to see if this behavior can be tracked to specific browser extensions?
Wow, what a great question. So to answer exactly, the answer is no, I haven't considered that. No, I haven't made such a collaboration. I would certainly be interested in doing so, but whether the browser or browser extension folk are willing to work with us in this data area remains to be seen. But that would be a very interesting area of trying to understand what's going on here. Thank you.
Our next question is from Warren Kumari. Have you done correlation in where the original answer was served to and where it gets looked up? In order for queries to be replayed, they presumably have to have seen the queries either in the DNS or through, for example, one of the leaking browsers / browser extensions.
Yes, it's sort of too much material to put in these slide packs, but yes, we've been looking at same country zombies, same AS zombies, same country zombies, different country zombies, where the query is sort of picked up in one part of the world, but replayed from a resolver system that is located in an entirely different part of the world. And it's kind of fascinating to look at this and understand, where is this replay activity actually coming from? To what extent does a single country dominate this area? When we did a similar exercise in the web quite some years ago now, we found a certain browser that included pinyin character input was almost a massive fingerprint of web replay. But DNS replay, yes, we have done that correlation, and certainly we'll be writing up the results in the near-term future, but too early or too much information to put in this pack.
David Malone asks, you mentioned that there is a heavy tail. if you look at median query age for those networks, does it look different to average query times?
Well, that's what I tried to look at with that average age from each of those resolver origins, trying to find basically the median time. And certainly there is a sort of a bimodal distribution that a certain number of resolvers are replaying quite old queries, and a different set of resolvers is actually replaying near to real-time queries. So the age distribution tends to reflect that initial distribution that we saw, where there's a pronounced peak of quite mature vintage DNS queries that are being replayed today, and a different set of close to real time.
Alexander Mehrhofer has asked, could it be that some of those early zombie queries are queries to refresh a cached name before TTL expiration?
Oh, totally, totally. There's this, I think it was called Hammer. Warren can probably correct me if I've got it wrong, but yes, we certainly expect that the recursive resolver, which would normally be caching and absorbing the repeats if the repeats are happening down at the stub, the recursive resolver is actually doing this as a cache refresh. The TTLs on these names are tight. They're 1 hour. But oddly enough, it's only the 1 hour query that gets the most. So does Hammer only work once? Is this Hammer? Interesting question. I should probably look more closely at the first 3,600 seconds or first 7,200 seconds to see if there is a peak at the DNS TTL refresh time. It is likely that that would contribute to the first round of repeats.
John Todd asks, on the long-term zombies, greater than 1 week, the smoothness of the patterns would lead me towards a hypothesis of a single organization or algorithm doing the queries. What do you see as a pattern, if any, of the ECS data on these queries, given that Google, the biggest zombie source, can include ECS data with queries, or is there no ECS payload?
This experiment does not deliberately trickle ECS. We try to be, I suppose, respectful in some ways of the amount of data that's flying around. And while I think we already know who the end user is, we certainly don't normally put ECS up there. ECS is also, I think, only just hitting, in big terms, the 3 to 4 year old maturity date. So I'm not sure, even if we had it on 3 years ago, to what extent ECS data would be sitting there inside the sort of old age queries. I do find it odd that Google is handling this insofar as, are these log replayers or active agents who are doing this analysis basically sitting behind Google and sending stuff to all eights that then, does a resolution as necessary? Or is there something else? I can't tell, at least from this data, exactly who or what is doing the original query. All I can tell is, head and shoulders, Google is doing most of it, and the stuff that Google is doing is 3 years old. Thanks.
Okay, we only have a few minutes left. I'm going to cut off the mic line. I'll go with a comment from Warren Kumari first, and then on to the next question. A comment from Warren is, some of this also comes from middle boxes, like exfiltration detection from, for example, banks.
Yes, we've certainly seen log replayers happening, where someone will take a web log at the end of the day and then reanalyze the web log. And sometimes that analysis actually does a DNS query as well. So we have seen, because this experiment we do does web and DNS, a correlation to some extent of web and DNS replay. So yes, I think there is a certain component of that, Warren, I agree.
Eric Zegast asks, hypothesis, did you try cross-referencing with web fetches? Is it possible a web crawler or malvertising related crawler found your ad and then requeries later over time? Multiple, I'm sorry, go ahead.
The answer basically is yes, but again, this is a massive amount of work. The last time I looked at this was about 5 years ago, and the concentration at that point was actually looking at the web, not the DNS. So we started with both web and DNS queries and looked for web replays where we had DNS replay matches, And yes, there was a certain amount of crawlers going on. But interestingly, in the web replay, what we saw was a particular browser was sending all of its URLs back to a data center located in China, actually. And that data center was reanalyzing that real-time feed. In that case, the query delay, the zombie delay, was astonishingly short, 2.76 seconds. And this technique we've used in the DNS, where we're using a resolution of 30 seconds, would not normally have picked that up. So, you know, when you get down deeper into this and correlate web and DNS, you actually expose another dimension, which in our case exposed the really fast zombie stalking queries that happen almost immediately after the original. It's a fascinating area.
Brian Dixon asks, did you see any changes in patterns when global travel plummeted? For example, could some of the signal have been generated by any of the activity occurring as a result of travelers?
If you can see a pattern in this graph between January and May, when global travel kind of stopped around March and April, you're probably a better man than me. I can't see anything there. What I can see in the data, and that's a different kind of question, is enterprises use Google and OpenDNS more than ISPs. When everyone went home, the weekday-weekend pattern changed, and the weekdays became more like weekends. But that's who you ask, not the volume you ask. This zombie querying didn't really change across that period, no.
Okay, while Warren Kumari comments, the hammer/precache document suggested that this only happened in response to an incoming trigger query.
Oh, so someone else would have had to have made it first. In that case, Warren, my explanation or my theory is blown up, and I am bereft of any further theories.
Hazel Smith asks, also for the opposite case, for example, queries that are duplicated very soon after the original query being sent, could it be due to, for example, internal timeouts between front ends and back ends in larger provider environments, resulting in the query being resent via a different RPC backend and thus going out onto the internet again?
Oh, totally. When you look at this closely, and particularly when you look at queries coming from resolvers in the same /24 or /48, what you actually find is there are times when the load balancers or something goes completely screwed, and every single slave sends you the same query back to back. And so, yes, load balancers misbehave. We get massive amounts of that over time. And so, yes, part of that is that the load balancers don't always gently field the query to just one engine. But, you know, from time to time, one of them goes nuts and just simply sends it to everyone because, you know, you can't query too often.
Okay, and our last question from co-panelist Duane Wessels. Do I assume correctly that in the AD code, these queries probably originate with a web fetch? If so, there is a web component in addition to a DNS component, ? The web component, proxies, logs, etc., may contribute to zombie queries?
Yes, indeed. These queries were originally delivered to the user as a URL. So yes, there is a web component, and most of the time, with some deliberate exceptions, the web server will answer, and so there will be a web log as well. And so as an earlier participant had questioned, you know, did you match web to DNS? And the answer is, we see web to DNS matching. We see that. But oddly enough, the DNS zombie rate is much, much higher than the web zombie rate. So we're seeing the DNS actually have a subtly different profile to the web zombie rate. And that, I suppose, is itself a topic for yet another talk.
Awesome.
Assuming anyone's interested.
Great. Thank you very much, Geoff, for joining us so early in the morning. We do appreciate it.
Oh, well, thank you. And thanks to Joelle for helping me with this work. Thank you.
Indeed. All right, with that, we'd like to hand things back to Keith to handle the closing remarks.
Okay, so thank you, Dave and Jake, for chairing the sessions today. The thing I'd like to emphasize today is basically, as ever, OARC workshops happen because they have a support of a lot of people. We've been able to make this workshop free for everybody to enjoy. We'd hope to be able to continue to do that, but we'd also want to make sure that everything continues in a sustainable basis. So we're going to run a poll, and we're just going to see from that poll and get some feedback from you that we can use to work with future workshops. So that poll should be appearing now. And if everyone could respond to that poll, that would help us plan future workshops in terms of frequency and duration and how we fund these. And obviously, please complete the surveys as well. I apologize for the problem that happened with the per talk surveys. That has now been fixed. Would also appreciate feedback on the workshop itself. Other support that we get. We're able to do this because OARC receives financial support from a bunch of sources. VeriSign in particular, our workshop patron, they funded our physical workshop costs in February and continue to support it. OARC members and supporters, they're basically what is paying for the time of the OARC staff to run these events. We also receive grant funding from a significant number of bodies now. So please, I'm not going to list everybody who does that, but it's an increasingly important part of what we do. I'd like to thank the program committee, especially Dave and Jake, who basically ran this particular workshop, but in general, the program committee are always putting together the agenda for the next time and reviewing all the content, all the content and presentations, and all of our speakers. They had to give up more time than just what you've seen in the presentation today, because we had a whole bunch of rehearsals and everything to make things smooth. I'd ask you to please consider supporting an OARConline event. We had an audience of 250 people today, so if you support such an event, then you get visibility with a bunch of people who are key in terms of running the DNS. And you can do that via patronage, where you support our workshops through a year, sponsorship of an individual event, or we will be happy to accept on one-off donations as well. So you should have received in the Zoom chat room and or by email details of the social event. I know it's not the same as getting together in the same room as everybody over drinks. Hopefully you've got some beverage of your own to bring. There's the meeting ID, the password or the click on URL. You should look in the Zoom chat room for the event, or you should look in your inbox, and hopefully you can join us very shortly for that. Please let us know what you thought in terms of the surveys. The other thing I'd just like to draw OARC members' attention in particular is I posted the quarterly member report yesterday. You can also download that from the event site. We're pretty transparent about what we do, but hopefully there's some updates about what OARC has been doing over the past few months while we've all been locked down and doing other things. While everything is locked down, we plan to hold further OARConline events until physical meetings are feasible again. How often should we have these? How long should these meetings be? We'd appreciate feedback on that in the survey questions, so please let us know so that we can plan them in future. We're continuing to plan the physical meetings that we had intended, but that's very much subject to pandemic developments, and I don't think anybody on the planet really knows what's going on there. So what's planned for future workshops? We had been hoping that we would co-locate OARC 33 with RIPE 81 at the end of September. Obviously, these plans were looking fairly shaky even before RIPE decided that they're going fully online. You may have noticed that this workshop is targeted at the US and Asia Pacific region. The next one, if we do OARC 33 online, we'll do our best to target that for the European time zone. We had some plans for cooperation and co-location of that. Watch this space in terms of partnership. It's also quite possible that we will have another short online event before OARC 33. We've already decided that the members AGM, which is usually with the autumn meeting, will take place online on the 28th of September, possibly the day after. We're still hoping that we might be able to do OARC 34 co-located with NANOG in February next year, but I don't think anyone really knows. So watch this space. I'd just like to finish. Many of you, it's great to see so many OARC members participating. It's also great to see so many people that we haven't seen at OARC workshops before. If your organization is not an OARC member and you want to support what we're doing and enjoy the benefits of being an OARC member, hopefully you can use these points to win the discussion within your organization. And that's it basically. I'm done. Thank you to everybody who supported the workshop and for your time and participation. Hopefully it was interesting and worthwhile and not just another Zoom call. See you in the social room very shortly if you're able to join us.